This video is in continuation to the previous video, differentiation of trigonometric functions. Here this sum is little different and of higher level compared to the previous sums which we have done in the last video. In this sum, the question is to find the coordinates of the turning points and determine whether these points are maximum or minimum points. Regarding turning points, maximum and minimum points, we have already studied in your previous class. Anyway, we will just brush up what is stationary point and how many types of stationary points are there and which are they. So any point on the curve where gradient is equal to 0 is called the stationary point. So at stationary point, the gradient is 0. So it's clear. And at stationary point, the gradient of the curve and the gradient of the tangent equals 0. And there are three types of stationary points: minimum point, maximum point, and point of inflection. At minimum point, the P is at the base, and at maximum point, the vertex P is at the top, as you can see on the second image. And the third type of stationary point, which is called the point of inflection. Here you can see the gradient changes from positive to 0 and then to positive again. So that means the curve after stationary point is not bending downwards, it is still rising upwards. The other case is the second diagram shows the gradient changes from negative to 0 and then again to negative. That means the curve has come downwards, and after this stationary point, the curve is still going downwards. So this third type of stationary point is called the point of inflection. Now, what is minimum turning point and maximum turning point? Now, the question is, how will you determine whether the points are maximum or minimum points? At minimum point, dy by dx changes from negative to positive, and so the gradient of dy by dx is d squared by dx squared will be greater than or equal to 0 at the minimum point. Now, if you consider the maximum point, dy by dx changes from positive to negative, and so the gradient of dy by dx, that is d squared by dx squared, is less than or equal to 0. This is for maximum point. Now let's move on to the sum. Find the coordinates of the turning points on the curve y is equal to 2 sin x plus cos 2x for x is between 0 and pi, and determine whether these points are maximum or minimum points. So always when we get this sum, we have to start by finding the gradient, that is dy by dx. So let's start this. Dy by dx is equal to 2 cos x minus sine 2x into 2, or we can write this as 2 cos x minus 2 sine 2x. Now we know at turning point the gradient is 0, that means at turning point dy by dx is equal to 0. So this implies 2 cos x minus 2 sine 2x is equal to 0. So there are some common factors, and before that we can make some changes here. Sine 2x means 2 sine x cos x. So now we have 2 cos x as common factor. 2 cos x into 1 minus 2 sin x is equal to 0. So this implies 2 cos x is equal to 0, or 1 minus 2 sin x is equal to 0. 2 cos x is equal to 0 means cos x is equal to 0, or so for what value of x cos x is equal to 0? X is equal to pi by 2. X is equal to pi by 2. So cos 90 is 0. Now here 2 sin x is equal to 1. So sin x is equal to 1 upon 2. We know for what value of sin x it is half. So it is sine 30 or pi by 6. So we will write in radians. So x is equal to pi by 6. Now we have a range of values for x between 0 and pi. If we go for another value of x, it will be 5 pi by 6. So another value is, and x is equal to pi minus pi by 6. This is equal to 5 pi by 6. So we have these values. X is equal to pi by 2, x is equal to pi by 6, and x is equal to 5 pi by 6. So we have 3 x values. Now for each individual value we will find those coordinates of the turning points, starting with when x is equal to pi by 2. So when x is equal to pi by 2, so what we can say, d squared y by dx squared is equal to, now we have to differentiate again the gradient. So this is the gradient. So we have to differentiate this. So when you differentiate this, you will get minus 2 sin x minus 2 sin 2x means 2 sin 2x into 2, that is minus 4 cos 2x. So derivative of sin x is cos x. So this is equal to minus 2 sine, we will substitute the value for x. Sin x is pi by 2 minus 4 cos 2 pi by 2. This 2 and 2 gets cancelled. So this is equal to minus 2 sine pi by 2 minus 4 cos pi. So this is equal to sine pi by 2 is 1, sine 90, sine 90 is 1. So minus 2 into 1 is minus 2, minus 4 into cos 180 is minus 1. So this is equal to minus 2 plus 4 is 2. But this 2 is greater than 0. As we have already discussed, if d squared by dx squared is greater than 0, it is minimum. So we can say therefore minimum. Now we have determined that it is minimum. Now we have to find the y coordinate of the turning point. We know only the x coordinate of the turning point. So when x is equal to pi by 2, we are going to find the y coordinate. So it is given in the question, y is equal to 2 sine pi by 2 plus cos 2 into pi by 2 is cos pi. So this is equal to 2 sine pi by 2. 2 sine 90 is 1 plus 0 cos 180 cos 2 sine pi by 2. Pi by sine 90. Sine 90 is 1. So 1 into 2 is 2. Sorry, it is not 2. And this value is minus 1. 2 minus 1 is 1. So we can say pi by 2 1 is the minimum turning point. Pi by 2 is minimum turning point. Now second case, when x is equal to pi by 6. When x is equal to pi by 6. So when x is equal to pi by 6, we can say d squared y by dx squared is equal to 2 . It is d squared y by dx squared is equal to minus 2 sine x minus 4 cos 2x. So substituting the value, minus 2 sine pi by 6 minus 4 cos 2 into pi by 6. So this is equal to minus 2 sine pi by 6 means sine 30 is 1 by 2. 1 by 2 minus 4 cos 2 and 6 gets cancelled to pi by 3. So pi by 3 means 60. So cos 60 is 1 by 2. So this is equal to minus 1 minus 2 is equal to minus 3, which is less than 0. So if d squared y by dx squared is less than 0, it is maximum. Therefore, maximum. Now we are going to find the y coordinate. When x is equal to pi by 6, y is equal to 2 into sine pi by 6. Sine pi by 6 plus cos 2 into pi by 6. So this is equal to 2 sine pi by 6 is sine 30. Sine 30 is 1 by 2. So 1 by 2 plus cos 2 pi by 3. It is 1 by 2. So this is equal to 1 plus half is equal to 3 by 2. So therefore pi by 6 3 by 2 is maximum turning point. Maximum turning point. This sum is not over. We found only for two values, x is equal to pi by 2 and x is equal to pi by 6. Now we have to find for x is equal to pi by 6. I think there is no space. Anyway, I will write a small brief about this. When x is equal to 5 pi by 6. So when x is equal to 5 pi by 6, d squared y by dx squared is equal to, we know the derivative. It is minus 2 sine x minus 2 sine x minus 4 cos 2x. 4 cos 2x. So we will put the value here. It is minus 2 sine 5 pi by 6 minus 4 cos 2 into 5 pi by 6. So this is equal to, I will use the calculator, minus 2 5 pi by 6 minus 4 cos 2 into 5 pi by 6 together. It gives the value, just a minute, I will use the calculator. It gives the answer minus 3. So minus 3 is less than 0. So if d squared y by dx squared is less than 0, therefore maximum. Now we will find the y coordinate when when x is equal to 5 by 6. Y is equal to 2 sin x plus cos 2x. Cos 2x. So this is equal to 2 sin 5 pi by 6 plus cos 2 into 5 pi by 6. I will use the calculator and tell you the answer is it is 1.5 means 3 by 2. So 3 upon 2. So 3 upon 2. So from this we can say therefore 5 pi by 6 it's not become 5 pi by 6, it's disturbing me. 5 pi by 6, 3 by 2 is maximum turning point. Maximum turning point. Okay, let's move on to the next sum. Show that the maximum value of the curve y is equal to x minus 2 sin x for 0 less than or equal to x less than or equal to 2 pi is 5 pi by 3 plus root 3. Now here also in this sum, we will find the gradient first, then at turning point, the gradient is equal to 0. We will find what are the values for x, and from there we will find out the maximum and minimum turning point. Okay, question number y is equal to x minus 2 sin x. So dy by dx is equal to 1 minus 2 cos x. So at turning point, dy by dx is equal to 0 means 1 minus 2 cos x is equal to 0. So 2 cos x is equal to 1. Cos x is equal to 1 by 2. This implies for x is equal to pi by 3, cos x is 1 by 2. There is one more value for x because the range of value is given 0 to 2 pi. Now if you look at the graph of cos x, here I'll show you. You can see the red curve. This is the graph of cos x. Now pi by 3 is here somewhere. Let us suppose pi by 3 is here. So this is pi by 3. Now it is between 0 and 2 pi. So 2 pi means there is one value here somewhere in between. I can focus this one here, because since this is the symmetrical line, this is the symmetrical line, the distance from here and distance from here both should be same, and those values lie between 0 and 2 pi. Now we need to find what is the difference between pi and pi by 2 and pi by 3. What is the difference? So we will find out what is the difference. Pi by 2 minus pi by 3. So this is 3 pi minus 2 pi by 6. So this is equal to pi by 6. So the distance between this is pi by 6 between. So what we have to do with 3 pi by 2, we have to add pi by 6. So we will get 9 pi plus pi is equal to 10 pi by 6. So 10 pi by 6 means 2 5s are 10, 2. So the answer is 5 pi by 3. So apart from pi by 3, we have one more value. X is equal to 5 pi by 3. So these are the two values which we are going to use to find the minimum and maximum point or maximum value and y coordinates of the turning point. When x is equal to pi by 3, d squared y by dx squared is equal to derivative of the gradient. So this is the derivative. We have to find this second derivative. So d by dx of dy by dx. So it will be 0 minus 2 sin x so it will be 2 sin x minus 2 into minus sin x. So it will be 2 sin x. So this is equal to 2 into sine pi by 3. So this is equal to sine pi by 3, 2 into sine 60. So root 3 by 2, 2 into root 3 by 2 is equal to root 3 is greater than 0. So we can say it is minimum. So minimum. Now we are going to find the y coordinate. When x is equal to pi by 3, y is equal to x minus 2 sine x is equal to pi by 3 minus 2 sine pi by 3 is equal to pi by 3 minus 2 into sine pi by 3. So root 3 by 2. So this 2 and 2 gets cancelled. It is root 3. So we can say pi by 3 and pi by 3 minus root 3 is the minimum turning point. Is the minimum turning point. Now students, I am leaving the second part of this sum to you. And what is that second part? when this one, when x is equal to 5 pi by 3, you have to find d squared y by dx squared, and then you have to find the y coordinate of the turning point. So this is left to you. Now moving on to the next sum. If y is equal to ln root 1 minus cos x, you have to show that d squared y by dx squared is equal to 1 by 2 into cos x minus 1. So dy by dx is equal to ln root cos x, root 1 minus cos x is 1 by root 1 minus cos x into root of 1 minus cos x is 1 by 2 root 1 minus cos x into derivative of minus cos x is sin x. So this becomes sin x by 2 root of 1 minus cos x into root of 1 minus cos x is 1 minus cos x. So this is actually dy by dx. Now d squared y by dx squared, again finding this second derivative, again deriving. So d squared y by dx squared is equal to, now this you can see this is quotient rule. We know the quotient rule, d by dx of u by v is v into du by dx minus u into dv by dx by v squared. So this becomes 2 into 1 minus cos x into sin x is cos x minus sin x into 2 into 1 minus cos x is actually 2 sin x. 2 sin x upon 2 into 1 minus cos x the whole squared will be 4 into 1 minus cos x the whole squared. So this is equal to, we will open this bracket, or we can, okay, 2 minus 2 cos x into cos x minus 2 sin squared x upon 4 into 1 minus cos x the whole square. There could be another method, but I have chosen a different route. So this is equal to 2 cos x expanding minus 2 cos squared x minus 2 sin squared x by 4 into 1 minus cos x the whole squared. So this is equal to 2 cos x. Here you can see, if we take minus 2, this will become cos squared x plus sin squared x. So this is equal to we have the denominator divided by 4 into 1 minus cos x the whole square. So numerator will be 2 cos x minus 1 upon 4 into 1 minus cos x the whole square. Since it is square, we can write the as cos x minus 1 the whole square. Both are same. So 2 and 4 gets cancelled. So numerator is cos x minus 1 by 2 into cos x minus 1 the whole square. We can cancel cos x minus 1 from both numerator and denominator, and we will get the answer 1 by 2 into cos x minus 1. This is the final answer.